Am I? Well, good morning, everybody. This is Thomas Ott for NeuralMarketTrends.com, and you're actually seeing me. I'm going to turn this off in a minute so you don't see my crazy hair after I have a sip of coffee, and then we'll get started on our next Learn RapidMiner live stream. All right. So, anyway, good morning to everybody, and let's shut off this video. Okay, great. So once again, welcome to the third edition of Learn RapidMiner live stream. I'm happy you could make it here today. This live stream is really set for people who are interested in learning how to use RapidMiner to accelerate their data science. You don't need to be a coder. It's a visual programming platform, but you can do R and Python, and I'll show a little bit about R later on today. And what I'm going to do is offer the chance for you to ask questions. Whether you can do it live here or you could do it afterwards in the comment boxes on the YouTube channel, NeuralMarketTrends.com. A couple other things to know is I do run a blog. You can also reach out to me there. Let me go screen share myself here into recursion. All right, let's come over here. So I do run a website, neuralmarkettrends.com, where I make posts on my blog and so forth. But perhaps the best thing to do is to go to my tutorials page. There's lots of tutorials here that you can learn on how to use RapidMiner and other things. And if you do want to get in contact with me, because Neural Market Trends is a data science consultancy. I am a RapidMiner ambassador and a former RapidMiner employee, so I know the platform very, very well. And I'm here to provide data science services or data analytics services to you. So you can come and reach out to me, find my email. It's kind of buried in here. I kind of hid it. So if you want to reach out and contact me, go over here to the guest posting and read that so you can maybe try to figure out what my email might be. All right. I'm trying to spam protect myself there. Okay, so let's start off where we left off last week. So last week we were doing some word to vector model building using one of my colleagues' processes that he shared on the RapidMiner knowledge base, which happens to be here on the community. You can definitely go take a look at this. If I type in word to vector or vec, you could see here there is a knowledge base article on synonym detection. And so what we're going to do is we're going to continue with that process. I stopped off on that process because I didn't realize that it would take about 45 minutes to train the model. And I did that after I closed the live stream last week, and it went ahead and finished. So we built a model, and we're gonna touch base, or we're gonna continue after that. So just so you know, if you go to the community.rapidminer.com, you can pull down this process from this knowledge base article here on the bottom. There's a processes.zip, and then you can unzip them, and then you can use them. So let's go take a look at what they look like. So come over here. I'm going to load up my live streams processes here from last week. And last week we did this. We ended the live stream by running this training process over here. We had loaded in some raw data, which was from, I think, TripAdvisor information. Let's see if we can load this in here. While this is running, it takes a few minutes, and we trained a model, and then we stored the model. Now, this was taking a long time. And what we're going to do after this is we're going to load the model in. We're going to extract some synonyms, which we're going to use later on for some stemming information in another text processing operator. So we're just going to show you on how you can actually then build that. And you can actually save this stemming dictionary to an example set and then use it to load it into your process later on. So while this is running, we're going to talk a little bit more about what else you could do with the word to vec operator. For example, you could attach it to a Twitter process, and you can extract Twitter information, look for synonyms there. There's a lot that you can definitely do with it while this is loading in. I did share a process on how to use word to vec in a very basic form also on my blog under the tutorials section. So we're going to pop over there for a second. And you can definitely get it over here by going to tutorials and then going to word to vector over here. I share the process. And in last week's live stream, we did talk about how to share processes in RapidMiner, whether through the XML window, which is what I have here, the XML, or through importing and exporting an RMP file, a RapidMiner process file. So come over here, grab it, and then show you populate that. Watch that video to see how you actually populate it into the window. And of course, if you get stuck, go to the community. There's a knowledge base article on that I believe Ingo Merswa, our founder, the founder, one of the founders of RapidMiner, wrote over there. So let's just go back to RapidMiner here. Let's take a look. Well, it's still taking a few minutes to load. Okay, here we go. So you can see here that it cut multiple documents. It did some text processing to it. And we are going to take this information and now we're going to load it into the model to get some synonyms. So let's come back over here. I'm going to go back to the design. I'm going to stop this process and I'm going to open the last one that Martin shared with us. Get stemming dictionary. Let's open this one up. Say no. And what we do is we retrieve the model here, okay, which is the model that we created when we were running. So if I were to maybe open this, I'm sorry, wrong one. Let's go back to the stemming dictionary here. If we were to open this model, you could see here that it has 19,736 words to it. And we're going to load this in. And then we're going to use a new operator that came with this particular operator toolbox. We're going to extract the vocabulary, and we're going to extract the top 1,000 words of it because we don't want to take all 19,000. It'll take a little bit of time to work. And then what we're going to do is we're going to change some of the roles here. We're going to set the word column to the ID role. And then we're going to make some multiplications. We're going to calculate some cross distances using cosine similarity. And then we're going to do a little bit of post-processing over here where we're doing some filtering. We're creating a similarity threshold, and then we're generating a stemming rule using a generate attributes operator. So the stem rule is really a little bit of concatenation, a little bit of some functions here which you can write as well inside the generate attributes operator. I've said it before on some of my older videos that the generate attribute operator is one of the most powerful operators in this RapidMiner platform. You can do a lot with it. Now, it's really what it means, generate attributes. And once again, an attribute in RapidMiner is really a column. So you'll hear these terms interchangeably, just so you know. An attribute is a column. Sometimes you'll hear it as an attribute column. And an example is a row. So sometimes you might hear people say example rows or an example set, meaning a group of rows, right? So this is just some little minor language tweaks that you need to be aware of when you hear them thrown around when you're dealing with RapidMiner processes and so forth. So don't get confused. An attribute is a column and an example is in a row. So there you go. All right. So let's go run this process and work our way through it. So first, what we're going to do is we're going to do a breakpoint here, and we're going to load the model in, and we're going to extract the top 1,000 examples. And you can see here are the words, okay, and here are all the various dimensions of the word to vector model. It goes about 100 dimensions or so. Actually, it is 100 dimensions and all regular attributes, 101, including the word. And then what we're going to do is we're going to set that role. Remember, we're going to change that word to an ID. And we're going to put the breakpoint after that. I'm going to put a breakpoint after cross distances. So now we change that word column, that word attribute column, into a special ID role, which means it just flows effortlessly through the process. It's not being used. We're going to use the dimension columns to figure stuff out after this. Let's go back to the design here. And let's go do cross distances. And now we're actually beginning to do some analysis. We're going to calculate the similarity between all those dimension vectors here. And you could see here if I went and did a sort by distance, you can kind of see where they're all different. All right, so the higher the distance, the more they're further away. So if I did a distance of 0, well, that makes sense. So night and night are the same, time and time, and so forth. But if I keep scrolling down, let's just see where we start seeing some divergence here. So kids and children, all right, 0.49, still pretty close. Beds, right, 0.49. And as we get further away, the meaning may be a little bit different. Weeks and days, 0.7, okay, days are in weeks, so forth. They may be time related, terrible, bad, and so forth. So you begin to actually create some insight, or you begin to actually prepare the data for some additional modeling later on. So that's how really it is just to use the cross similarity data right there. So let's just go back to the design and let's see what else we need to do. We're going to do some post-processing here. Let me get rid of these breakpoints. Get rid of them here. And let's take a look in the post-processing. And what we're going to do is we're going to put breakpoint here. And we're going to put a breakpoint here. We're going to do some sorting and then removing the synonym duplicates. And then what we're going to do is we'll put another breakpoint here to see the stemming rule. Okay, so we'll run it again. Now it's going to be sorted. You can see here we sort. And I believe it's based on the distance. Yep, looks like it's ascending. And then we're going to now remove duplicates. So we have 939 examples. We're going to remove any duplicates. So this number should be lower. And it is. It's 459 now after remove duplicates, which is good. So we're making the data set more lean, but more packed with good information. And finally, we're going to now generate the stemming rule. And so now here's the stem rule. Now this information will be used in another text mining process using another operator, which I'll just touch on. You can then use this information to build your own stemming or build your own filtering processes in RapidMiner using the text processing extension. So let's come out over here. Let's go back to the design. And what I'm going to do is remove all of these breakpoints now. Go up one level because now I've generated the stemming rule, and I'm going to store it. I'm going to store it locally. Right? It's called replacement dictionary. We run that, and now it's done. Now it's done. Okay, so now I have my request, my concatenated document, and my stemming rule, right? Above, below, truly, absolutely, adequate, small, so forth. All these various rules that I can use to stem my dictionary or stem my text binding process. So how would that look? You could do something like this. Click on New. And you would then, let's say, we're going to save this dictionary. And then we're going to look for the operator toolbox, which is also a fantastic extension. And then we're going to take the replacement dictionary. I'm going to do something like this. Connect it in like that. And maybe we do a create document. Do a very, very simple process here. We'll just say, I don't know, test this testing document for weeks and days. We'll see here what happens. And then we're going to use the attribute for, I think, stem rule here. And we're going to run this and let's just see if it works. And it did it stem anything? I don't think so. But anyway, but you get the point. So this then would be embedded inside a text processing process documents and so forth. And then you can use and replace it just like that. So that's actually really how you begin to use the word-to-vec extension in conjunction with creating stemming or filtering or other different things. Very, very powerful little operator that was just recently added to the operator toolbox. So definitely check it out. Definitely use it. There's been a lot of questions on the community related to how to use Twitter and how to do synonym detection and so forth. So based on the process that I shared over here and the processes that Mr. Martin Schmidt shares with you, you can definitely cobble this together. You can see here there's a word-to-vec process or operator extract vocabulary. You just need to go ahead and add the other processes behind it here and go from there. There you go. And that's how you actually do it. Okay. All right, great. So let's talk about another favorite topic of mine. It's time series today. So I'm going to talk a little bit about time series, and then I'm going to open it up to any questions that may be out there. Okay, so with RapidMiner, there are multiple ways to analyze your time series. I guess the question comes, you know your time series better. Are there things like seasonality in it? Are there things like not seasonality? Is there a trend? I mean, there's certain different things that you need to look at when you're analyzing a time series. And a lot of times, it's going to be a domain specific type of function. meaning that you know best. Like, for instance, I had a client, they sold products, and typically the product would spike around Thanksgiving. They had a specific product that was related to cooking. And you would then see that, okay, well, there's a big effect happening around Thanksgiving, which may skew the results in the trend. Now, overall, the trend was up, but if you took into account that spike, the trend would be obviously very biased in that particular case. So what we did was we used a little bit of R to actually deseason the trend, and you could do that. Once again, RapidMiner is a data science platform. Does not lock you into specifically just using RapidMiner. You could use Python. You could use R. There are extensions to use the Octave, which is a clone of MATLAB. You could use the execute program operator to execute some things in MATLAB natively and kick back the information. So it really is meant to be a platform. So you can add different tools into your toolkit, whether you use Python or you use R or something else. You can all wrap it together with RapidMiner. And if you go on the rapidminer.com website, there are a couple of presentations. The one of them that comes to mind is the Capius Tech one, where they actually use call center. They wrapped Python and R into RapidMiner as a way to do some analysis for call center voice, voice to speech type of thing. So that's definitely a really, really cool thing to check out as well too. So let's go take a look at doing some time series. Okay. While I'm loading this up, let me just stop sharing for a moment. And let's just see if there are any comments. Okay, there are no comments. Excellent. And let's go back to sharing here. Recursion. Okay. So RapidMiner uses a model approach to time series. And it's a little bit hard to wrap your mind around it. My old friend from Semaphore posted a good article about the differences between time series and RapidMiner versus the standard R type of stuff, where RapidMiner looks at a cross section of data. It's very model based type of analysis, but you can definitely do different things with it, such as adding a little bit of R. You can do that too. So we're going to take some time series sample data here, and we're going to just build a windowed process, a model-based approach to using time series here, using the monthly milk production data set. So let's go load this up. Let's go run it, and let's take a look at it. So we have some dates. It seems to be a monthly type of time series. You can see here by monthly milk production, pounds per cow. And if we look at a chart of the data, you could see here that there are definitely some peaks going on over here. And it looks to be very seasonally enhanced or seasonal. It looks like my initial hypothesis is that it looks like there is a lot of seasonality in it. It looks like it may be in a somewhat of a trend and maybe flattening out over here. But let's go analyze it the RapidMiner way, and then we're going to analyze it with a little bit of R. Okay. So how would we start building a RapidMiner process using the time series extension? Well, the time series extension is called the value series extension, I believe. We'll come over here. And let's go look under extensions, and it is actually, yes, the value series extension. So a lot of my earlier videos on my YouTube channel for RapidMiner 5.0 used, I think it was called something else, but uses a windowing operator. And we're going to use that again here. And I'm going to try to be very clear in explaining to it, because it is a little bit confusing at first. There are quite a few posts on the community about how to use the windowing operator. So bear with me. If you do have any comments after this video, just of course ask them on the YouTube channel or on my blog. But what we're going to do is we're going to just inspect a few things in the value series operator extension. So we have cleansing operators, remove missing values. We have extraction operators, extracting peaks and max mins. We have transformation operators where you can window or you cut the series. We also have some basis transformation if you're interested in doing like fast Fourier transformation and so forth of the data. And of course, filtering, doing some exponential moving averages, some lagging and some other different things over here. And we have some utility extension, utility operators, data transformation, and of course, evaluation using a sliding window validator, which is essentially backtesting. Okay? A lot of people get confused. What is sliding window validation? How is it different than cross validation? And here's the key difference between the two. In cross validation, okay, if you're using a standard cross validation, whether it's set to stratified sampling or linear or what have you, it will randomly take chunks of data from your time series and try to make a prediction. You would think that's the right thing to do, but it's not. Because in time series, the actual series going from one time period to another actually matters. So if you start slicing it up randomly, you will not get the right answer. So with the sliding window validation operator, what you do is you create a window over your time series data, and then you slide it across. Like say, for instance, you want to go from year one to year two, and you have maybe 100 years of data. So you would create a window to go from year one to year two, build a model on that data, then slide it to year two and to year three. And you would slide it across your data, and you would build a model for each one of those windows. Okay? There are ways to combine all those windows into one model, or you can actually then use each window, of this case a year, to test forecast performance or maybe a root mean squared error or something like that on all the other windows and see if the model for that particular window is any good across the other windows. Okay. Oh, let's go load up the windowing operator first. So that's also a term confusion here. There is a windowing operator, and then there is a sliding window operator. So people will get confused on those two, and we're going to go through the differences in that in a few minutes here. So let's go look for the windowing operator. What does the windowing operator do? Okay, the windowing operator will take your data set, and this is where it will create a cross section of data. Okay. In our particular case, we have only one attribute column here. We only have the monthly milk production. Okay. You may have multiple time series data points, right? Multiple, meaning, say, for instance, if you're looking at a time series for financial data, you might have open, close, high, low, and so forth, and volume. You may want to include all those extra columns in a way to predict your future forecast or something like that. So you might want to create a window that contains all that data. So that contains the cross section of the data. Okay, so what we're going to do here is we're going to window the milk production. Now, this is on a monthly basis. So we may want to create a model that will take a cross section of milk production for 4 months. So I want to create a window that will include 4 months of milk production, okay, to try to predict 1 month ahead. Okay, so we're going to take a window of 4 months of milk production and then create a forecast for a in this case, a horizon of 1 month ahead. Okay, so let's go back and do that. And we're going to see how RapidMiner will actually then convert that data. So I take my windowing operator. And the parameters here are going to be very important, very, very important. We're going to the series representation is also it's a very important parameter, but it's often misunderstood. In this case, the series representation, you're going to encode it based by examples. So it's saying that the time series will go from row to row. Like if I look over here, go back, it's going to be each row will have a new point in the data series. Now, you can also have the data series in your data may go across columns. In that case, it'll be encoded by attributes, right? The default will be examples because that's typically how we load a lot of data in. But in some cases, you may actually have data coming from one particular machine, let's just say, and that happens to be across multiple attributes, thousands of attributes per machine. And you may actually have your data set to, each machine is an example row. So you can encode it that way as well too. So it gives you that ability to do it, but we'll use a default example. Now here's our window size. Remember we talked about using a window of 4 months. So we're going to change this to 4 months. Okay, and this is where you control that. The step size is going to be 1. Okay, now what does that mean? So you're going to say we're going to create a window that's 4 months, and then we're going to move it 1 month ahead. So the window shifts 1 month ahead, but it will always remain the size of 4 months. Okay, so this is important, right? So let's just say if we go look at our data here, we are going to create a window from December to March, and then we want to predict April. Well, then when we're done predicting April, we want to create a window for January through April to predict May. And that's what the step is. The step is 1 month ahead. You can, of course, change it to 2 months if you like, but we're going to keep it simple and we're going to use 1. Okay. Leave this default on, create single attributes, and you can also leave this default on to stop on too small of a data set. Now, if I just run it as it is, we'll see how it transforms the data. Okay, so I created something very interesting here. So now I have created, if I open this up, actually this is going to be a little bit hard to read. So I'm going to add a rename here. So you can see, we'll add a rename. We're going to change that name to just milk column because this is just too crazy. Say milk. And then we're going to run this again. And then you could see it a little bit easier here. So what it does is it creates a window for March 31st, right? So milk 0, I'm going to sort this up again. Milk 0 happened to be December 31st. Milk 1 is January 31st. Milk 2 is February, I think, 28th. And then milk 3 should be March 31st. Okay. We're going to try to use these 4 things to try to predict April 30th. But how do we actually do that? How do we actually do that now? We don't have a label. We need to create a label that will transform this data into a column that will say to the RapidMiner algorithms and analysis that this is what we want to predict. So how do we do that? Come back to the process, click on the windowing operator, and create a label here. Okay, very simple. So we toggle it on, and if you toggle it on, you'll get some extra parameters to select. But we're going to select the label attribute. We want to say that we want to create a label using the milk column. Okay? So select that. And what we're going to do is we want to tell RapidMiner that we're predicting 1 month ahead. It's different than the step size here. The step size moves it 1 month ahead. It could be 2 months ahead. But the label horizon here says I want to predict 1 month ahead or 1 time unit ahead. Whatever your time units are, it's that time unit ahead. Right? So let's just put a breakpoint here. After the rename, we'll see what the raw data is going in, right? Remember, we had December 31st was 589, 561, 640, and 656. I think I was a little bit off. My apologies. We'll correct this in a second. I was reversed. And now if I run the rest of the process, we now have this. My apologies. Milk 0 is actually March 31st. Okay, March 31st. Milk 3 is actually December 31st. I apologize. I would have had them reversed here. But you can see how it transformed this information. So now where did 727 come from? Where did 727 come from, right? That wasn't part of March 31st. Well, if I come over here, let's go back to design. And I just look at what the data, if I run this again, 727 should be the milk production of April 30th. And there it is. You see here? So what it did was, it took a window of 4, okay, meaning milk 0 is this, milk 1, milk 2, milk 3, okay, and said, I want to predict April 30th. I want to predict what I want to build a model so that I can predict this value of 727. No matter how good it is or how bad, but we want to try to predict this value. Okay. And so when we ran the process, when we ran the windowing, we took December, January, February, March to predict April. Okay. So now if I look down over here, I have April in here. Okay. So now we take January, February, March, April, right? Because April, this is the number, these numbers, April, to predict May. Okay. Then now I look at what's going on in May. I have I have February, March, April, okay, May to predict June, and so forth. And this is how it creates the window. This is how it creates a cross section of data. Okay. Now you may notice that, hey, I'm missing some information here. What happened to December, right? It starts at March. Well, RapidMiner is pretty smart. It gives you that option here to either add incomplete windows or not. If you want to see the entire data, which actually will have, you could see it right here. It has all these missing values. You can actually put that in there. You would just have to replace them with some values. That would really be up to you. I normally don't do that because I just hate doing extra ETL steps, but you can do that if you like. You can see that entire data, how it gets transformed to do all that by just toggling that off, okay? So now we actually have some data that's ready to be put into a sliding window validation operator. Now, mind you, I build a cross section of data. Now, this data takes 4 months, moves it ahead by 1 window, and creates a horizon. So now let's actually try to build a sliding window valid. Let's actually try to build, I don't know, maybe we'll use maybe a neural net or something along that line to actually try to see if we can predict this information. We're going to try to do a forecasting performance, and then we're going to try to do maybe a root mean squared error. Let's try that. Okay, so we go to our sliding window validation operator, drag it in. Okay, and we'll talk about this in a second. We're going to maybe take a neural net. Do a very simple neural net. In here. Oops, sorry, connect us. And we're going to do an apply model, right? This is the training side. We're going to apply the model on the testing side. And we're going to use the forecasting performance operator. Now, the forecasting performance operator is just analyzes the direction of the trend. Can it actually get the trend correct based on this data? Okay. So it's going to give you a percentage in decimal form. So now let's go back and let's actually figure out how we actually configure this. So we have the sliding window validation operator, and now we have these new parameters here. We have a training window width, training window step size, test window width, and the horizon. This is where the confusion starts. And let's take this slow. So the training window width, okay, will be, if I toggle on breakpoint here. Okay, I'm sorry. Let's go disable that for a second. The training window width will be this data. Will be a window using this data. So if I have a training window width of 10, it would take all this data and build a model from it. Okay. If I have a training window of, say, 20, it would take this. It would take 20. Okay. If I then had a testing window, okay, of, say, 5, it would build, and a training window of 10, it would take 10, and then it would test on the next 5 to see if this model can accurately predict this test data set. Okay. The step size is here. The step size means how do you move the window forward. So in this case, if it's set at 1, well, then you take the next 10, move forward, and then take the next 5 to test. Okay? The horizon for the windowing operator, the sliding window operator, is really the distance between the test and the training window. So if I had let's say I had a training window of 10, a test window of 5, but I had a horizon of 2, I would skip these 2, and then I would have my test window here of 5, right? So that's how that works. That's how that works. So now I'm building a cross section of data, and I'm going to create a back testing model, sliding window, by creating windows over that cross sectional data. Okay, that's really the difference here, and that's why it gets confusing. So we're going to do this here. We're going to create a window of 10. Let's say 10. And we're going to slide it 1. And we're going to create a test window of 5, horizon of 1. Okay, we'll talk about cumulative training in a moment. Let's go run this. Okay, I'm sorry. Yes. All right, we'll get rid of this. We'll rerun it. Oh, and I forgot to add this one. So one of the things too is when we're trying to determine the horizon of the forecast performance, we really want to know 1 month ahead. So in this case, this becomes 1. If you want to know 5 months ahead, technically your performance will begin to get worse because, well, further out you forecast, it gets a little bit harder. But in this particular case, the performance we're going to say is 1. Okay. All right. And we're going to do that. All right. Let me go back here, test this out. Good. Okay. Now we're going to run it. Okay. Oops. Did I actually output the? Oh, sorry. I meant to output the performance. There we go. Let's run this again. So actually, we got a pretty good model. We actually get a pretty good trend prediction. We got a 67.7% forecast trend accuracy. That means we're pretty confident 67% of the time we can forecast the trend, okay, whether it goes up or down. What happens if we want to actually do maybe say a root mean squared error? How close are we actually to it? So we would then just swap that out and we would do maybe, I think it's a regression. Perf, actually. Let's look for perf. And we would then toggle on root mean. Let's just say root mean. And we'll see how good we are here. So we actually have a root mean squared error of 62. So we actually have 62 plus or minus 24. So it's probably somewhere between 86 to whatever that is, 30 something units off. So if we look at our data, our monthly production can be predicted, say 35 to 85 units off. So that may or may not be what you want, but we can do other different things with it. Now that we have a basic model here, right? We have a basic model here. We can do optimization. We can do parameter optimization because maybe I don't know what this training window width is. Maybe I don't know what this width should be to get the best performance out there. Okay, so how do we do that actually? How do we actually create that type of model? It's very, very simple. So we come over here and we do an optimized performance. Optimized grid, also known as hyperparameter tuning in other lingo, like if you're a Python guy or gal, pardon me. I'll put the performance, I'll put this, parameters, paste this back in. And now what we're going to do is we are measuring the performance of the root mean squared error. We want to get this as low as possible, right? So this is why the main criterion is set as first. We can actually set it at root mean squared. So we're actually optimizing. We're going to optimize the model to get us the lowest root mean squared error. Okay. But what we're going to do is we're going to try to do it by windowing. So I come over here. Let's come back, go up one level. I'm going to click on this and I'm going to edit the parameter settings. And what I want to do is I want to vary the windows. I want to vary my training window. I want to vary my test window. Okay. So I'm going to go from, in this case, 2 to 10. And I'm going to go from 2 to 10 for this one. I'm going to use it in 10 steps. So I have 81 combinations here. Okay. And I think what I need to do is, let's run this for a second. I think I might have to add a minimize one here. So one of the neat things is that as this is running, RapidMiner creates these grid rows right here. And you can see here, it's calculating all the various combinations of the validation windows. And it's saying that the smallest root mean squared error of 52.13 was achieved with a training window width of 10 and a test window of 10. Okay, so there. So now you can say, well, what happens if I actually include the windowing operator? Maybe I'm not windowing my data correctly. Let's go paste this in here. We can come over here, connect that, and now we're going to go back and we're going to then say, click over here, and we're going to select the windowing operator, and we're going to say window size. Originally, we had it from 4. We're going to say 2 to 10. Now you can see that the parameters keep increasing, and I'll remind you that this is going to be higher runtime. So if you have if I see people make all these different types of parameter optimizations with like 100,000 different combinations, and they're running it on an 8 gig machine, and then they wonder why it's taking 500 years. Well, that's why. So just be aware of this. There are other ways to get around it if you use the evolutionary parameters one. But remember, this is a very intensive, computer intensive type of analysis here. We'll come over here, we run this. It may take a little bit longer now, but as it's running, we go to results and we can see what it's doing over here. So we sort by this, sort by the lowest. And it might not make a difference here, or it might. We have to go through 800 different combinations. While this is running, I'm going to see if there's any questions. I'm going to stop sharing for a moment. And, okay, no questions. Excellent. Let's go back to sharing. Recursion. So while this is running, let's go talk about something else. Now, if we remember looking at this data here, the data actually was quite, appeared to have quite a bit of seasonality to it. So how do you actually strip out all that seasonality, and how do you actually get to the right trend? Well, we're going to do this right after that. And then we're going to call it a day. So we're crunching. I'll take a sip of my coffee. And while that's running, I'm going to grab, let's see, do I have any messages? No. Let's take a look at the results. It looks like this might be the best. Actually, no, we might have something lower here. And we can actually, while this is running, we can actually chart this. We can say, look at this. Let's see here. We'll choose the color. Oh, okay, so here we say windowing size of 3, 10, and 10 gives me this root mean squared error. Very good. We can actually chart this. Let's just take a look at this chart real quick. If I wanted to say window validation width, training width, and testing width, and I say root mean squared error, you could see here that in blue down here, this is where you need to be. So let's go do this. Actually, let's go on the right. Let's go do this. Root mean squared error on here. And we're going to say windowing size here. All right. Actually, no, that's right. We're going to do training test window. So you can also see down here, right? You can begin to see that the root mean square error is lower based on this color point over here. So you can do different things while you're looking at this. Now, what the neat thing is with a new parameter optimization algorithm operator is that depending on how many optimizations you do in performances, it'll actually list them all automatically. In the old days, we had to create a log file, and that was a pain in the butt because sometimes you would forget about them. This is actually a very nice enhancement. Very nice enhancement. So that's really a basic primer on how you do time series with a cross-sectional data slice using windowing and sliding windowing operators in RapidMiner, and some optimization to boot too. Very helpful when you're trying to make time series predictions. Now, what about using RapidMiner to deseason some data? Well, I'm going to save this here, save this process as my live streamer, and say milk with RapidMiner. And what we're going to do is we're going to use some R this time around. Okay, I had created a process earlier here just to test it to make sure my R works. And we called it milk and R. Okay, we'll do this. So same thing. In this case, I renamed the milk production or the milk value column to something called value. And I did this because I have some pre-canned R scripts that have data frames already set in them, and I call out the word value. And I keep the same types of variable name declarations because it makes it easier instead of me hunting through all the script and changing everything all the time. So what I did was, in this particular case, I just renamed the milk column, which is what I was interested in, to the name value here. So if we looked at the data again, let's go back to the data, and we looked at the time series of this. We could see that, right? We originally saw that at the beginning of the video here, that we actually have quite a bit of peaks here. And the hypothesis is that there may be some seasonality here. So how do we actually get rid of that information? Or how do we actually extract all those components, the random component, the trend component, and the whatever the value components are in RapidMiner? Well, the easiest thing to do, we'll start out first with an execute R operator. So I have R already set up here. If I go to my preferences, I have the R scripting operator set in here. I have a path to where my R script exe is. If you need to get the R operator, go to the marketplace, look for execute R. And you can see it here. We got Python and R. We'll talk about Python another day, but you can install the R scripting extension here. And what it does is it gives you a neat little operator. Execute over here. And you can actually paste in your R script. You just have to do it in this function code here. And you need to install the data tables library as well, because that's how RapidMiner converts the R data frame into the RapidMiner data frame or data structure, and then back and forth. So you can do neat little things here with R. So there you go. So you can actually start leveraging the power of your R scripts and reusing them over and over again, or sharing them with friends and so forth. Once you put this into production using a RapidMiner server, which will be a live stream in the future, you will see how powerful this really becomes. So in this particular case, what did I have here? I have a simple R extension or R operator, which I actually created as a building block right here that I reuse over and over again. I need to learn to spell better. And let's take a look at what it does. All it does is it takes the value column, creates a data frame, says the frequency is 12, which is 12 months. And it deseasons it and generates a plot after I deseason it. And then I also dump some of the information to a summary, which will show up in the log file. And then I save the plot file, the PNG file. And we'll actually take a look at it in a second. So I hit apply and I run this. And as you can see here, it's running, and it's doing some stuff. Okay. So it says, hey, I saved the file here, which will open in a second. But let's just take a look at the design window, the log window here. You can see over here, okay, so it did a couple things. Okay, here's actually my results. A little bit hard to read, of course, in the log file, but it did do something. So let's go to the actual directory here. We're going to copy this, and let's go open up my Windows Explorer, paste it in, load it up. And there you have it. Let's just see here what's going on. And it actually created a plot file. So it says here, okay, here's my data. Here are the seasonal components. Here's the actual trend. And here's the remainder. Here's the random components of that data. That's awesome. This is great if you want to use it into a report, right? This is how do you actually then take this information maybe and enrich the data set with it, with RapidMiner. You can do that too by just a little bit of more R code. Come back over here, go back to our design. Let's disable this and let's enable this new one here. And let's take a look at it. All I'm doing is the same thing. Frequency is 12, deseasoning it or decomposing it. And here now I'm outputting a couple things. I'm outputting the seasonal, the trend, and the random. Okay, I'm actually taking this data and I'm returning it. So I can now do that. And there you go. Now I actually have the components of the milk production. Now you may say, oh, I want to add the milk and so forth. You can definitely add the milk. You can definitely add the, you could just change your R script a little bit to pass the milk value through it. But there you have it. This is how you do this. And this is how you can take a little bit of R or whatever you need to go ahead and create a process in RapidMiner. Okay. And this is where I'm going to stop for today. In the next video, we're going to maybe show you how you can actually maybe use some Python and do this as well too. But first off, I do want to say thank you to RapidMiner for giving me a shout out this week about this live stream. I really hope that this has been very informative to you. My name is Thomas Ott, and I do run neuralmarkettrends.com. And now this is where I ask a little bit of your help. Please come visit my YouTube channel. Okay, come over here. Please visit my YouTube channel and subscribe to it. Okay. You can definitely find me here at neuralmarkettrends.com and click on the notification bell wherever that might be and go from there. And this will let you know if we have more upcoming live streams or we have data that's being or new videos being uploaded. So once again, Thomas Ott from neuralmarkettrends.com. Thank you so much for watching. Reach out to me if you have questions. See me on the community.rapidminer.com or visit me on neuralmarkettrends.com. Thanks so much. Happy mining and have a great, great weekend.